Hello guys, the last tutorial, tutorial 8 of circuit and electronic. Here we are going to cover, so question 1 is for the common emitter amplifier shown in this figure, VCC given, R1 also R2, so all the values given by here. Beta is 100, VT 25 millivolt, VBE assume 0.7. Then calculate the DC bias current, IE, if the amplifier operates between the source for RS is 100K and the load is 2K. Replace the transistor with its hybrid pi model and find the value of Ri, which is the resistance input, and output means VO over VS and I over IS. Okay, so for DC you should turn off all the AC source, then the capacitors also be infinity. Then if you look at this as I show in this circuit, so R Thevenin and V Thevenin given by here, R1 in parallel with R2, and V Thevenin is R2 VCC R1 plus R2. So by here V Thevenin is R2 by here, as you can see. Let me change the color. R2 and R1 given by here. Then VCC is given by here. The value of VCC is 9 volt. So calculated V Thevenin equal to 3.21, and R Thevenin as mentioned R1 and R2 in parallel. Then IB as you can see by here again, here as the same as this one. Turn off the VBE, this one, the AC source, is V Thevenin minus VBE over R Thevenin plus RE beta plus 1, which is going from somehow is the same as the circuit is not this one. This is the source RBB, this is our BJT, and this is RE. So this is beta. So from here to here you can calculate the IB, then beta is given, so IE and IC can be calculated easily. Then the small signal parameter, we should focusing of course here are available. GM is IC over VT and R pi is beta over GM or VT over IB. So IC we calculate, IC is 1.92 over VT given 25 millivolt. Then the R pi is beta, which was 100, 100 over GM, you calculate by here, and the R pi also calculated. So the model for small signal analysis, we should remove the DC source and short circuit the capacitor. Then the pi model, here for be careful about PNP and NPN and PNP, the direction of the dependent current source. Then from this view, when we replace VS, RS, R pi and R Thevenin connected in parallel, you can see by here Ri, which consider from this point, R pi and R Thevenin in parallel. So V pi, which is the voltage across this, is Ri times Vs, this is the Vs, over Ri plus Rs. It's very clear, I think. So then we can find out the V pi over Vs and V out, which is here, and we know the value of this one, which is minus GM times V pi for this one. The minus is because of the direction of the current. This is from this way to this way, this is from other way, or you can consider from minus to positive, up to you. Times here RC parallel with RL. So V out and V pi can be calculated by here. Then AV, which is V out over Vs, can be considered as V out over V pi, then V pi over Vi. You can write down which is equal V out over Vi, not Vs, over Vs. So 1, 2, both of them are here. I out, the current of here is V out over RL, very clear. And I input, the current of here is Vs over this total resistance here. Then I out over I input in the same way can be calculated using the values. So very simple, this one. Next one, let beta be equal 25. Then VBE given 0.7. Determine the range for V1, range of this one. In a way, VCE, this one, can be changed from 1 to 4.5. Then find out the equation or draw the range for Q point. Okay, for this one we should calculate the IB first, because the beta is given by here. So for IB, as the VBE given by 0.7, we can have I for the I across R1. The I across R1 here is VB by here. This point is VB. So V1 minus VB over R1, V1 minus VB over R1 is equal to this current, we call it I1, and VB, this is I2, VB minus 5, which is VB plus 5, over R2 divided over R2 give us a current. So the current IB, which is here, is equal I1 minus I2. Then as we know the beta, we can calculate IC and IE. Then for drawing or sketch the Q points, as I mentioned, we need to have equation from VCC to ground, from here to here. So this equation, VCE equal VE or VE, VCC minus RCIC. Then the range, because we don't know V1, then the range can be find out if we put VCE by the minimum and the maximum. Then you can find out the values for V1 and IC. As you can see, if VCE equal to 1, so V1 become 3.95, and IC, the collector current, is 4 milliamp. And in the case the maximum one, the V1 become 1.83 and the collector is 0.47. So this is a simple one. Next one, this circuit asks you to find out RB in the way that overdrive factor equal 10. The BJT is specified to have a minimum beta of 20, and VCE in saturation value is 0.2 volt. What is the force value for beta? So in the first step, step 1, you have to find out the minimum IB, which is, so you have to find out IC over beta. So beta is given by here. So IC can be calculated from this equation, from here to here. So VCC RCIC. Then the ISAT means IC in saturation is given by 4.8 milliamp. Then as we know, beta equal 20. So as we know, beta equal 20, the IB value becomes 0.24, and override factor, which is IB, beta times IB minimum, is given by here. Override value is 10, so 10 times this value is 2.4 milliamp. Then you can calculate the RB as equation from here to here, of course. Then the IB can be found out, and the force beta, which is asked by here, what is the force beta? The force beta is step number 3, IC sat over IB actual. So we know IC sat, which is this value, and the IB actual, which is this value. So the force factor is 2. Next, the circuit is given. Next, ask you find out ICQ, VCEQ, plot DCAC, and calculate the small signal and determine the input, output, RIB and RO. Beta is given 120, VBE 0.7, and VA is infinity. So for this circuit, in the step 1, as you saw for the question number 1 also, remove this one, R1, R2, you should find out by this one, RBB, this is RBB or R Thevenin, up to you, and V Thevenin also in the same way as I showed. So the circuit change such as this one, V Thevenin, R Thevenin, this is VB, VC, VE, and you know the connections. So R Thevenin become 5, V Thevenin minus 5. Then you are going to find out the IB from here to here, but as we have value RBB, means the current here is IB, the current here is IE, and we know IE equal beta plus 1 IB. Then here you can see minus V Thevenin, R Thevenin IB plus 0.7 from here to here, beta plus 1 IB RE, which is this one is IE, minus 10, which is here, equal to 0. So IB, IC and IE can be calculated using this beta 120 beta. The DC line, for DC line again you have to write down an equation from here to here, and then IC equal to 0 and VCE equal, or VCC equal to VCE equal to 0, and find out the values, and this is the points. Then a small signal GM, VT is given by here 26 millivolt, GM as mentioned by here again IC over VT, and R pi is VT over IB or beta over GM, up to you. So you can calculate both values. Then easily a small signal equivalent, we are going to find out the RIB. RIB is the values for the major problem here, I think in the tutorial given RC parallel with RE, RC and RL are not parallel here, so these two are parallel. And here as you can see the coefficient beta plus 1 for me, meaning that it should be in the emitter which send it to the base. So RB is seen from this point, This is for this one. Then the value is 122.5 K, and R in, which is seen from this point, without this one, still without this one, from this point of view. So R Thevenin in parallel with RIB. Then the value is given by here. So AV, in the same way as we calculate for the previous one, you can see again the major, I think, should be RE parallel with RL, so times beta plus 1, then R pi, and for the VB over VS, R in plus RS, the final value is given by here. Again, for R out, RC is parallel with this value, which is R Thevenin in parallel with RS. So for this analysis, you have to consider this one as a short circuit. So these two are connected in parallel, correct? Plus R pi, still correct. Then we are going to send this one to RC. So for this to be parallel with RC, so I think this one should be beta. However, you can chasing and searching which one is correct. For me, both value beta and beta plus 1 cannot give me this value. I don't know how this is calculated by here. So the last question, consider the common emitter amplifier circuit shown in figure. The AC source shown in series with DC supply source represent power supply HUM throughout the small signal equivalent circuit. Be sure to include the HUM source in your model. Notice VHM0, the two equivalent circuits are identical. Find expression for the voltage given V in over V out if VHUM or HUM is 0 and then V in 0. Then the value is given by here: VCC, beta, RB, RC, and VB. Which circuit is the best? And you should choose. So it said if we're going to first again DC analysis, you need remove this one VCC. This is short circuit. Then you can find out this is short. You can find out for both DC analysis. I'm just focusing in the same way as here. This is the BJT is replaced with a pi model. Then as you can see by here, if VHUM is 0, which is this one, HUM is equal to 0, what happened? V pi can be calculated as a V pi equal V in, because here is connected to this point. Then from this one, this is the output of, this is the V out, so V out equal minus GM RC, or minus GM V pi times RC. Then you can calculate V out over V in, which is this value. Then in the case V in becomes 0, when V in is 0, which is this one, so the 0 is here, and then the A HUM is calculated based on this formula, should be given in the book and in the slide, and you have to focus on this part which is basic signal transistor amplifier, and this summary of CE. For B also we need, I cannot find, maybe your slide is updated. So for you, I think better to memorize this one. If we have such a circuit, A HUM, we out over V hum equal to GMRC, is RC prime, but here RC prime means in parallel anything else we have. So RC, the total RC we have. So here only we have 4.7. So the value become 2.259. And in the case of circuit B, which is this circuit, again, we should calculate the DC, then going to the other side. So if V in V hum is equal to 0, what happened? In the same way as the first one, the value become minus 259. You can calculate by yourself. But in the case, the second case is the important one. When we in equal to 0, IB becomes 0, so IC again becomes 0. Then there is no current, as I mentioned last time. No current, no voltage drop, so V hum equal to V out. Then, as we know, V over V HUM. So VHUM is the same, V out and VHUM are the same. So A HUM equal to 1 based on the Bowers analysis configuration. 10B is preferred. Okay, wish you best.